Hi, my name is Pavel. I've got here a short presentation of the program for sheet metal components manufacture using a press brake. Everyone who deals with this kind of manufacture knows the problem of generation and optimization of bending sequences. The key task is finding the number of feasible bending sequences from the overall number of theoretical combinations. The theoretical background of the problem and the program itself are described in the enclosed article. Here I just want to show you how this program works. Just one more thing, the program is an artificial intelligence based one, and the core of it is an algorithm designed and developed on the basis of some of the methods from operations research for solving exhaustive search related problems. I will not tell you now about the software or hardware platform it runs on. I will do it at the end of the presentation. So here we go. The program's name is TOBS, Tool for Optimization of Bending Sequences. So let's start. Let's say we want to manufacture a sheet metal enclosure as in the picture here, using these couple of tools. Here you see the blade and the base. So we select the option Enter New Geometry and start to input one by one the geometry of the enclosure in the Cartesian coordinate system. We will start with the component. Okay, so any of the points, either the end points of the profile or any of the bends, can be the center point with the coordinates x and y equals 0. I will just demonstrate the input process on a couple of points. Okay. I will name the component T101/12. Okay. And let's start inputting the points. So the first point would be x0, y0, okay. Next point would be -20, 5, okay, and so on and so on. So you see the coordinates as they pop up on the screen. Once you have done it, you would save your work. The same would apply to the tool. Just to make the presentation shorter, I have already saved both the components and tools, so we will not lose time with this and proceed further. So I will quit this menu, no save, and we'll go to quit this menu because we have already input the tool as well. Okay, now we go to the next option, and that is generate bend sequences. Enter. Again, we have to select the component and the tool. So the blade, the base, and generate bend sequences. The program now goes through a permutation tree, and here we go. 2 sequences here and a few more numbers related to them. We can see the number of horizontal and vertical turns for each of them, i.e. how many times during the manufacture of this component we have to turn it over or revolve horizontally during the bending process. There's one more factor displayed, it's CHF. It stands for the component handling factor, which reflects the number of turns and shows the manipulative complexity of the sequences. Now we can choose and save any sequence. We will save the one with the smallest CHF. In this case they are both the same because the component is symmetrical. And naturally, the smaller the number is, the less manipulation the enclosure requires during the manufacture. Enter. So we will choose the sequence number 1 OK, and save. Okay, that's it. This is not it yet. We want to also see the bending process based on the computed sequence. So the next option is simulate bending process. Here again, we have to select the component and the tool. So OK, and enter. Here is the initial setup of our tools and the component, which is placed on the first bend to be processed. On the left of the screen there is a flat geometry and its length shown as the neutral axis. So the first bend is 8. You can see it in the window on the right. Here we go. Let's hit B for bend. So we finish the first bend, and the next bend is number 12. We have to turn the component horizontally, not vertically, as it tells us the instruction in the window here. The program does it. Enter. And again, the current bend, the next bend, and so forth. We can also zoom or pan out. And let's go. B, B, so now we go one bend after another until the process is finished. Okay. So that is all. We see E at each of the instructions on the screen. That's all. Okay, now I would like to tell you more about the program. It's 23 years old, believe it or not. It runs under IBM DOS 4.01, originally on the IBM PS2 Model 30 computer. It's in the C programming language. So now you see why the interface is so simple and the resolution of the screen is so rough. This presentation is run on a bit newer hardware on the IBM ThinkPad 760ED, where I ported the program to, still under IBM DOS 4.01. Okay, that is it. In any case, should you find this interesting and would like to learn more about the program and the problematic, please let us know through the email here. Thank you very much.